Okay, what we're going to do here is we're going to integrate products of sines and cosines. These are trig integration. And we're going to focus on our powers here for sine and cosine. We're going to focus on odd powers. So that's going to be the focus of this integration technique here. So let's look at an example here. If they give us sine cubed x dx, this is going to be our approach. We're going to factor out a single sine from our integrand, our function here. Okay, notice the power is odd. So we factor out a single power of sine, we get sine times sine squared. And at this point here, we're also going to do the following. We're going to replace sine squared with 1 minus cosine squared, the Pythagorean identity. And so what you'll get here is sine 1 minus cosine squared, and this will be our integral dx. Okay, so here's the technique. I'll put this in red here, this Pythagorean identity. Now at this point, we're going to let u be cosine here. So since u is cosine, derivative of cosine is minus sine dx. So now our dx will become du over minus sine. So let's use this information here. Let's remember here that my u is cosine, so I'm going to replace this cosine here with u. And I can replace here, I can go through this problem with a u substitution where we have sine here, 1 minus u squared now. Now dx would be du over minus sine. And what will happen here is my sines will cancel. And I'm left here with that negative sign. So that's a constant. So I'm going to pull out that constant, or let's leave it here. We have 1 minus u squared now, du over negative 1. What this will give me is u squared minus 1 du. See, when I divide here by negative 1, my terms become opposite. So now I'm able to integrate. I'll have 1/3 u to the third power minus u plus c. Now let's go back and remember that u here is cosine. So my final answer here is going to be 1/3 cosine cubed minus cosine plus some constant c. Let's consider now another odd power of sine. Let's go to sine to the fifth power now. Now we're going to use the same approach. Here's what you're going to do. Again, you're going to factor out a sine from your integrand. So that'll be sine times sine to the fourth power x now. And you'll notice that sine to the fourth power can be written as sine squared squared. And using the Pythagorean identity for sine squared, that's 1 minus cosine squared u, or cosine squared. Let's just not get ahead here. So, okay. Sine 1 minus cosine squared squared. Now at this point again, since we're using u sub, u is going to be cosine again, which means du is minus sine x dx. Or we can actually say that du over negative 1 will be sine x dx. If we actually solve for, or let's say we can just divide both sides here by negative 1, that factor. We're going to use this information here. We're going to let u be cosine. So now I have my u here, and let's see what we get. Sine times 1 minus u squared squared. So remember, we're supposed to integrate this with respect to dx. Now, sine, I'm going to change the color here. Let's look at this here. Sine dx is really du over negative 1. So we're going to replace this sine dx with du over negative 1. So I get 1 minus u squared squared du over that negative 1. So at this point, we're going to use some algebra here. We're going to have to use FOIL here. So 1 minus u squared squared by FOIL becomes 1 minus 2u squared plus u to the 4th. So our integral will be 1 minus 2u squared plus u to the 4th. Don't forget we have a du over negative 1. We just use FOIL here. Okay, now we're dividing here now, again by that negative 1. That's going to change all my terms here. They're going to become opposite. So this integral will be now negative 1 plus 2u squared minus u to the 4th du. Integrating, I get minus u plus 2/3 u to the 3rd power minus 1/5 u to the 5th power plus c. And don't forget, u here again is cosine. So we have minus, let's write this final answer, minus cosine x plus 2/3 cosine cubed x minus 1/5 cosine of the 5th x plus our constant c. Okay, so we seem to have a pretty good grip on when we have here, and we certainly have a good approach when we're looking at an odd power of sine here. So notice again, this here is odd. And let's just actually look at another problem and say, what if they gave us sine cubed x? This time, let's give a cosine x here. Now we could do a cosine squared. It doesn't even matter. Okay, so what you want to notice again is you have an odd power here of sine. So there's that odd power, just like what we've had in the past. We're going to use this approach when we have an odd power of sine. Notice what this does then. We're going to factor out a sine here, and we get sine squared cosine squared. Now, we're going to use, for sine squared, the Pythagorean identity, 1 minus cosine squared. So altogether, we get sine 1 minus cosine squared, cosine squared. And again, we're going to let u be cosine. And when u is cosine, du is minus sine dx, or we should really say that du over that negative 1 will become sine x dx. We're going to divide both sides here by this negative 1. And so here's that factor down there of a negative 1. Now, since u is cosine, wherever there's a u, or I should say wherever there's a cosine, we replace it with a u. So here's a u. So finally we get sine 1 minus u squared. And remember, we're integrating with respect to dx. And so take a closer look again, and let's notice this part here. Sine x dx. Sine x dx is really du over negative 1. So if we replace sine x dx with du over negative 1, we get the integral of 1 minus u squared du over negative 1. Now let's remember what happens here with this factor of negative 1. We'll get an integral of u squared minus 1 u squared du. Now all we have to do is do some algebra and distribute here, and we'll get an integral of u to the 4th minus u squared du. So when you integrate, you get 1/5 u to the 5th minus 1/3 u to the 3rd plus c. Don't forget again, u here will be cosine. So, since u is cosine, our final answer will be 1/5 cosine 5th power of x minus 1/3 cosine 3rd power of x plus that constant c. And so this is what we do when we have an odd power of sine. So let's take a look at something that might look like this. Let's really kick this up. We'll have sine here to the 7th power x and just a cosine dx here. Now notice our power here for, let's change this. Our power here for sine again is odd. And we're going to go with that same idea. We're going to factor out a sine here. So we'll have sine to the 6th power of x cosine x. Now, I'll have to write this as sine squared raised to the 3rd power so that I can use my Pythagorean identity, being 1 minus cosine squared for that sine squared. And so altogether, what we have again is the factor of sine times 1 minus cosine squared to the 3rd power cosine x. Again, we're going to let u be cosine. And if u is cosine, du is minus sine x dx, or du over negative 1 is sine x dx. So, u being cosine, we're going to place our u, replace the u now with, or I should say replace the cosine with a nice u. So this is u. We get sine x 1 minus u squared cubed u. And don't forget, this is integrating with respect to dx. So at this point, it looks like we can now replace our sine x dx with du over negative 1. So we'll have an integral 1 minus u squared cubed u du over that negative 1. Or, let's put the negative 1 here. Well, let's keep that negative 1 there for now. What we're going to have to do now, here is some algebra. Okay, so we're going to have to notate this algebra. So I'm going to put this in blue here. We have 1 minus u squared. Now that's the third power times u, which will be 1 minus u squared, 1 minus u squared, 1 minus u squared times a u. We're going to have to multiply this out by FOIL. So let's write that down here too. We're going to have FOIL here and another FOIL over here. Okay. 1 minus 2u squared plus u to the fourth multiplied by 1 minus u squared times u. Now this is FOIL-ish, if you want to think of it that way. So I'm going to take this first term here. 1, I'm going to multiply by all three terms. So I get 1 minus 2u squared plus u to the fourth. I'm now going to take, let's change this here, the minus u squared and multiply it by all these terms here. What I'm going to get is a minus u squared, I'll put it down here, minus or plus 2u to the fourth minus u to the sixth. And don't forget, all of this is multiplied by that u outside. So we can simplify this here. We get 1 minus 3u squared plus 3 to the fourth minus u to the sixth times that u. Now distributing the u, we get u minus 3u cubed plus 3 to the fifth power minus u to the seventh power. This is what we're going to have to integrate with respect to u. Okay. We get now 1/2 u squared minus 3 to the fourth over 4 plus 3 to the sixth over 6 minus 1/8 u to the eighth plus my constant. So altogether, here's what we get. 1/2 u squared minus 3/4 u to the fourth plus 1/2 u to the sixth minus 1/8 u to the eighth plus your constant. Now don't forget what u is. U is actually cosine over here. So if u is cosine, we can now replace this answer with 1/2 cosine squared minus 3/4 cosine plus 1/2 cosine of the sixth minus 1/8 cosine to the eighth power plus my constant c. So this is what we're going to do here when we approach a problem that has an odd power of sine up here. Okay, similarly, remember how we started this. Let's go back to all the way up here to 1. We talked about what to do when there's an odd power of sine. We're now going to talk about what to do when there's an odd power of cosine now. Okay, so we're going to focus on odd powers of cosine. So go all the way down to this 7 here, an odd power cosine. So let's try to integrate now cosine cubed x dx. Now we're going to look at this integral in the same way we did the past. In other words, this time, instead of factoring out a factor of sine, we're going to factor out a cosine. So factor out a cosine term. That gives you cosine times cosine squared. So at this point, you're going to use the Pythagorean identity for cosine squared, which is 1 minus sine squared. So now you have your cosine 1 minus sine squared. And as you guys can guess, you're going to let u be sine now, not cosine, but sine. When u is sine, the derivative of sine is cosine. So here's what you're going to have all together. Cosine times, let's not forget, since u is sine, wherever there's a sine, we replace it with a u. So this will be 1 minus u squared. Now, we are integrating this with respect to x. So over here, we also know that cosine dx, here's my cosine dx, is simply du. So I can replace this with a du. So you get 1 minus u squared du now, which will give me u minus 1/3 u cubed plus c by power rule. Don't forget that u again is sine now. So our final answer is going to be sine minus 1/3 sine cubed plus this c. And this is how we approach, take a look, an odd power of cosine. And it's very similar to how we approach the odd powers of sines. It just has a different factorization and different Pythagorean identity and a different u. So we can continue. Let's try to raise this power here again and say, okay, we have cosine to the 5th power again, dx. Notice that power there is odd. We're going to factor out the cosine. So I have cosine now, cosine to the 4th power. Now, like we did with sine to the 4th, we're going to have to write this portion here. Let's do this way. Write this as cosine squared so that I can now use my Pythagorean identity for cosine squared, which is 1 minus sine squared. And then all together now, what you'll see is cosine times 1 minus sine squared squared. We're supposed to integrate this with respect to x. Now, as you know, u will be sine. And if u is sine, let's put it back over here. If we let u be sine, that now means the derivative of sine is cosine. So that this u here, which is sine, I'm going to replace my sine here with u. And we'll end up with cosine 1 minus u squared squared dx. So cosine dx here is actually du. So we're going to integrate 1 minus u squared squared du. This is where we're going to use some algebra. We're going to use algebra here. So let's focus on that algebra. When we say algebra, what we really mean is we're going to use FOIL. And by FOIL, we're going to end up getting 1 minus 2u squared plus u to the 4th. So this integral becomes 1 minus 2u squared plus u to the 4th du. when we integrate, we get u minus 2/3 u cubed plus 1/5 u to the 5th plus c. Now let's not forget that u again is actually sine. So final answer is going to be sine minus 2/3 sine cubed plus 1/5 sine to the 5th plus c. So it's a very similar process when we have an odd power of cosine. Now let's see what happens if I put, for example, an odd power of cosine and then maybe just some other power for sine. This will be a sine squared. We can have a sine, we can have a sine squared, it doesn't matter. We'd have sine to the 5th power. But again, notice our focus on this exercise is that we have an odd power of cosine. And so, again, we're going to factor out cosine. So we'll have cosine times cosine squared times the sine squared factor. Replace your cosine squared with 1 minus sine squared. So you'll get now cosine 1 minus sine squared times sine squared. And that's what we have to integrate with respect to dx. So there's your process again. U here will be sine, and du is cosine dx. So wherever again you see a sine, we're going to replace that with simply u. So here's what we end up with as an integral. The integral of cosine 1 minus u squared dx. Again, we'll notice that cosine x is du. Here's my cosine x dx. So cosine dx is du. And now that means I have 1 minus u squared du. So at this point, again, we use algebra here, meaning just distribute. Okay, integral u squared minus u to the 4th du. Now this becomes 1/3 u to the 3rd minus 1/5 u to the 5th plus c. So if we go back and remember that u is sine, we can now give our final answer. And this means that we have 1/3 sine cubed minus 1/5 sine to the 5th plus your constant c. Okay, let's take a look. We'll try one more here, and let's try this. We're going to integrate maybe, we'll see, cosine sine to the 6th power dx. Okay, now you're going to notice again, even though there is no power for cosine, the power really is 1. So that 1 is in fact odd. So you might say, then we factor out a factor of cosine. Well, it's already written as cosine. Sine to the 6th, we write as sine squared to the 3rd power. our sine squared here gets replaced with 1 minus cosine squared. So altogether, we have cosine times 1 minus cosine squared to the third power. Actually, let's take this all back. What do you notice about this here? This one's interesting. Here's what we could simply do. I'm going to let u here be sine. And if I do, the root of sine here is cosine. We don't even have to use a Pythagorean identity. So in this problem, since we can't factor out the cosine that's already factored out, we already have to the right, like up here, we already have a bunch of sines. This already has a sine, and u here is going to be that sine. So this integral becomes simply cosine times u to the 6 dx, because we replaced, again, u being sine, this is our u. Let's notice that cosine x dx is du. So I have a cosine x and I have a dx. So my integral will become u to the 6 du. Here's our integral. 1/7 u to the 7th plus c. Remember, u is sine. I'm going to just write the answer. So writing this cosine, having a single factor of cosine there, really worked to our advantage. We didn't have to go through and use the Pythagorean identity. But if we had cosine, maybe, let's change this. Cosine to the 5th power, maybe now a sine cubed dx. Notice something for this problem here. That power for cosine is odd, and that's what we're focusing on. That's an odd power. However, you also have an odd power here for sine. So let's point out that odd power. What you could do here is use either method. And I'm gonna do the cosine, factor out a factor of cosine here because that's what we're focusing on. But we can also use the method when we had an odd power of sine. So let's factor the cosine since that's what we're looking at here. And I got cosine to the 4th times sine cubed. And again, I replace this 4th power with cosine squared squared. So now I can use the Pythagorean identity of 1 minus sine squared. So let's see what this all is again altogether. We've got that factor of cosine. 1 minus sine squared squared sine to the 3rd power. I'm going to let u be simply sine. If that's the case, the root of sine is cosine. I'm going to plug everything in. If u is sine, wherever there's a sine, I replace it with u. Here and here. Here's what I end up getting. don't forget, we're supposed to integrate with respect to dx. So this is what we get just plugging everything in. And then now I have cosine x dx being du. Here's my dx cosine x. That's just my du. So we'll have an integral of 1 minus u squared squared e to the third power du. So this portion over here now, if we focus on it, we're going to use some algebra. So 1 minus u squared squared u to the third. Let's double check to see if our work is okay. Okay. Well, this becomes 1 minus u squared times 1 minus u squared u to the third. Here, we use FOIL. We'll get 1 minus 2u squared plus u to the fourth, u to the third, which gives you u to the third minus 2u to the fifth plus u to the seventh. This is what we have to integrate. We end up getting 1/4 u to the fourth minus 2/6 u to the sixth plus 1/8 u to the eighth plus c. Don't forget that our u here will be sine. So our final answer is going to be 1/4 sine of the fourth power minus 1/3 sine of the sixth power plus 1/8 sine of the eighth power plus my c. And that's pretty much how you integrate with these odd powers of sines and cosines. Now, I do want to note here a couple of problems. I do want to note some u sub problems. For example, if we start off with one of them, maybe let's say we had sine cubed, and this is going to be maybe 2x dx. Now we'll do some u substitution first, meaning my u here will be simply 2x, which means du is 2 dx, or d over 2 is my dx. This is a u subversion. The argument here is 2x for that sine cube. Okay, this gives me sine cubed of u, and instead of dx, because this dx is the same as that dx, which is du over 2. So I'll now have du over 2. What happens here is I have a factor of 1/2 I get to factor out. Properties of integration. So this will be 1/2 integral sine cubed u du. And all I now have to do here is integrate sine cubed u. Now I have a formula for this, and let's put this in red here, right? We have a formula. Now if you don't know the formula, what you would do is you derive it for sine cubed and you go through this whole process. Now I think that was the first page here, so we have to go all the way back 12 pages to find the integral of sine cubed u. There we go. It's the first problem we did. The answer is right here. Here's my answer. 1/3 cosine cubed minus cosine. So that's what we're going to use, but instead of an x, we're going to place it with a u. So it'll be 1/3 cosine cubed u minus cosine. Replace this with 1/3 cosine cubed u minus cosine u. You can say plus c. And remember, we multiply this whole thing by 1/2. We also replace our u here with this 2x. Okay, so u is going to be 2x now. So that'll be 2x, and that'll be 2x. So let's write down this final answer. We'll have 1/6 cosine cubed 2x minus 1/2 cosine 2x. You can say plus 1/2 c, but as you guys know by now, we could just replace this 1/2 c with just a c for constant, or a c1. We've discussed that in class. It doesn't matter. Or a letter d. It is a constant. So call it c, c1, whatever you like. Let's do this cleaner. I'm going to call this simply c. But this is how we do some u sub problems. If they give you, for example, I think we did this already, cosine to the 5th power of x, and let's just change this. We're going to change it to maybe x over 3 dx. Now, here again, we got x over 3. This is going to be our u. So u is x over 3. So that means du is 1/3 dx, or 3 du is dx. So by u sub, we get cosine to the 5th power of u now, and that's 3 du. Notice the constant. 3 we can pull out. So it'll be 3 times the integral of cosine of the 5th power u du. I now have to integrate my cosine of the 5th power with respect to u. Now, again, we have a formula. We did this already. We just have to find what it is. So I think it was way back here, cosine to the 5th power, that's sine. We need a cosine to the 5th power. That's cosine 3rd. There we go. Cosine of the 5th power. This is what we're looking for. We integrated this problem already, and we found, wow, it's sine minus 2/3 sine cubed plus 1/5 sine of the 5th power x plus c. Now, here's what I can do here. We'll write it all down. Let's see, sine minus 2/3 sine cube and I think that was plus 1/5 sine to the 5th power. Let's double check. Yeah, I think it's right here. There we go. It is plus 1/5 sine to the 5th power. Okay. So let's see what we get now. 3 times sine, that'll be u now, minus 2/3 sine cubed of u plus 1/5 sine of the 5th power of u. Plus that c. Don't forget what u is here. X over 3. So I'm going to replace this u now with x over 3. Here's your final answer. 3 sine x over 3 minus 2/3 sine cubed x over 3 plus 1/5 sine of the 5th x over 3 plus that constant. So I'm going to distribute now, multiply every term by 3. Here's that 3 here. Let's distribute. Final answer. 3 sine x over 3 minus 2 sine cubed of x over 3 plus 3/5 sine to the 5th of x over 3 plus, you might say, 3 times that constant. Well, 3 times a constant, yet again, is still a constant c. So this is going to be my answer. I'm going to write this as simply a constant c. So this is how we handle questions that will involve u sub.